I'm Anna McKie, and in this video we're going to look at outliers and how to test for them. So what are they? They are extraordinary or unusual pieces of data that are separated from the rest. Just even try and think about that word outlier. What does it sound like? Sounds like two words, out and lie. So it's unusual pieces of data that lie outside of the main set of data. So to test for outliers, we have to determine the boundary values outside which it would be unusual to find any further data. What does that mean? So maybe if you think of heights in your year level, let's say they're year 11 students, and you would think of where the majority lie, the average, and then you might think of shorter people or really tall people. And so at what point in time do they get classed as an outlier, or at what point are they just a tall person but within the majority? So we have to have a way of testing. And so we have to consider things like if the data is valid and must be kept in our analysis, and if it's not valid and therefore we need to discard it to ensure accuracy. So for example, if you're asking people for their heights and you weren't measuring them, you're just asking them, and some people gave silly answers like 30 centimeters tall or 5 meters tall, that wouldn't be valid, and you would discard that value. But at what point in time are outliers valid, and we should therefore include them? So we have to consider boundary values. So any data larger than the upper boundary could be an outlier. So we have an upper and a lower boundary, and here's the formula for how to calculate them. The Q1 and Q3 you're hopefully familiar with from previous videos. They're the quartiles. And so the formula is you take the Q3 boundary, so that's after you've had 75% of the data, and you add on 1.5 lots of the difference between Q3 and Q1. Now, if you remember from box plots, between Q3 and Q1, that's where the box lies, and so that's 50% of the data. So we're saying, let's take a boundary value 1.5 times that amount, and anything beyond that will class as an outlier. And obviously a very similar thing for the lower end, but this time around, instead of Q3, it's Q1, and it's a subtract because we're looking at that Q1 and then we're going away from that to the left, if you like. Okay, so let's work with an actual example. So we've got 24 data values here, and let's determine if there are any outliers within here. So to get the most value out of this, you would benefit from typing this into your graphics calculator and then looking up the 5-number summary so you can see the Q1 and the Q3, or if you just want me to do it for you, here we are for those values. So are there any numbers beyond that? Well, of course there are beyond that, but according to that formula for the test. So if there are Q1 and Q3, here's the formula. So we've got 52 for the Q3, as you can see there, adding on 1.5 multiplied by the difference between Q1 and Q3. So the big number take the small number, and we see what we get. And here's the list of numbers over here. So is there any data value greater than 55.75? Well, let's round up, greater than 56. Yes, there was one data value, 57. So at the high end of the data. But then you also might have to have a discussion, but is it that far away from the boundary, or is it quite similar to the rest? So this is where you have to use some interpretation. And let's look at the lower end. So same values again. The difference between them is still the same. I advise you to write out the formula each time. As teachers, we want to see what goes into your calculator you write on your page. So we want to see this step here. The Q1 value, subtract this time 1.5 times the difference between Q3 and Q1, and we get 45.75. Let's round that up. Well, actually, should we round down this time, down to 45? Are there any numbers below that? Well, yes. 45 and 41, which are in that data set, are below that boundary. So we would class them as two outliers present at the lower end of the data. Okay, there's some questions to do. Share this video with somebody else, perhaps in another school, that you think could benefit from this. Thank you.